Then what is a good algorithm for the online setting? So let's first consider a very naive algorithm called consistent algorithm. So where the input is of course the finite hypothesis class. So among hypothesis class we have to select one hypothesis to make predictions. So initially we can keep whole hypothesis in the hypothesis class, and for each iteration the learner receive instance and choose any hypothesis among the hypothesis class at time t, and then make prediction using the hypothesis h. Okay, so pt is equal to h of xt, and then receive true label yt. The true label yt comes from h star, the true hypothesis h star. Of course, h star is not given to the learner, so the learner has to find h star. And then update vt plus 1. Why we can update vt plus 1? Because we know xt and yt, we can erase some hypotheses that have different prediction with the yt. Okay, so we keep only hypotheses having the same predictions with the label. Okay, so when the prediction pt, when pt is not equal to yt, we can erase at least one hypothesis, the hypothesis used for the prediction. Okay, so after making m mistake, capital M mistake, then the hypothesis class vt, the cardinality of vt is less than or equal to the original hypothesis class cardinality minus m. Because at each mistake, we can erase at least one hypothesis. So therefore, for the finite hypothesis class, for any finite hypothesis class, we can easily define the m consistent h, which must be less than or equal to the cardinality of h minus 1 from this fact. Okay, we can do at most the cardinality of h minus 1 mistakes. Okay, but this is very naive approach. Just purely randomly choose one hypothesis and then erase hypothesis that does not match it with the true label. So we can do better using one simple trick. So the halving algorithm basically almost the same as the previous very naive consistent algorithm. Only this part is different but very powerful. So basically the setting is mostly the same. A finite hypothesis class we have. So initially V1, the set of possible hypotheses is entire hypothesis class H, and at each time we receive instance xt and then make prediction pt using a hypothesis in vt. But this little trick, halving algorithm, follow a majority voting rule. So we consider all possible hypotheses in vt and check the prediction of each hypothesis, and then follow the majority. So argmax, the cardinality, having the same output. So why we have to follow the majority? Essentially, when we make a mistake, then we can erase hypothesis that having the same mistake. Okay, so when we follow the majority vote and then there exists mistake, so when yt is not equal to pt at this moment, then which means we can erase this set. Okay, we can erase all the hypotheses having the same output prediction. And since we follow the majority vote, we can erase at least half of possible hypotheses. So that's why the name of this algorithm is halving algorithm. We can basically erase at least half of hypothesis whenever we make mistake using this halving algorithm. So the halving algorithm has this mistake bound, and the mistake bound is upper bounded by log 2 of the cardinality of hypothesis, because at each time we can erase at least half of hypothesis.